and welcome back to the Futureprint Virtual Summit. I'm Karis Kopp, and we've got a really interesting session and a really important topic coming up now. And I'm delighted to be joined by Evyatar Halevi, Business Development Director, HP Cytex, and Xavier Melis, Worldwide Category Supplies Manager, HP PageWide Industrial. And we're going to be talking about sustainable corrugated packaging with HP Digital Solutions. So thank you so much for joining me, Evyatar and Xavier.
Thank you very much. And I will just share.
Yep, I'll pass over to you to share your presentation.
Very good. So again, thank you very much. This session, as you said, is going to be focused on sustainability and in general in HP, how we treat sustainability, what's the importance and what we dedicate to it. And gradually we will focus into the very specific areas that we are operating in, and that's the implementation of digital printing in the corrugated industry. So to start with, sustainability for HP is very, very important. We see three major pillars that we are focused on. One is the planet, the other one is people, and the third one is community. In the planet pillar, we really look at the impact of us as a company and industry on the planet itself, be it emissions or waste or anything that has an impact, direct impact on the environment around us. And this will be basically the focus of our discussion as we move into corrugated. The second pillar is all around people, inclusion, and diversity, and how we promote and develop people, how we help them contribute more into the company and into their families and into their neighborhoods, and into the planet as well, of course. And the last pillar is about community. HP has many, many offices around the world, and everywhere we try to associate with the local community, help the community grow, develop, help them understand technology and how technology can help them. And basically HP is involved in all these three pillars, as I said before. But we also see value in this that goes into the very core economics of what every company, of course, operates by and appreciates. So in 2019 alone, HP tracked more than about 1.6 billion in new sales wins in which sustainability criteria were a non-consideration and were supported actively by the HP Sustainability Organization. So this is about 69% growth year over year in value of new sales influenced by sustainability impact. So we contribute to the economy. We see the return from it, not only on the emotional and the contribution level, but also in the very core economics and financial results. HP, by the way, was scored as #1 in North America as the America's most responsible companies. We are #1. This is a study that was done by Newsweek and Statista, and they did a survey of companies and individuals and brands, and it spans over a very wide range of scores, all around environmental, social, and corporate, and we are very proud of it. So the company invests a lot into the responsibility around us and sustainability, and it goes all the way from the CEO level to the very last employee, and awareness is key in here. There are very different metrics and scores in the industry in which HP is measured by, as well as other corporations, of course. We are part of the Global 100 already in the last 4 years as most sustainable companies. We are listed first in inaugural ranking, and there are many, many more scores that I will not go over in here, but we track it, we monitor it, we influence, We lead it, and it's very important for us, and we see the results as illustrated before. So with that, we are stepping into our specific subject of the day, which is our involvement in corrugated industry. So HP has made a decision to move into the corrugated industry and to help convert the industry from analog-based processes to digital-based processes, specifically in printing. We believe the influence is across the entire value chain and not just in the printing process itself. And we'll be talking a little bit about it. But as we did with any other activity that we are involved with in any other market, of course, sustainability is a major driver for us into making a change in the specific industry. So, okay, just a sec. It's moving independently of me. Let me. Okay, so when going into digital printing in packaging, even without the very specifics of what HP is doing, going from analog to digital, you already gain major factors in sustainability. Digital printing involves much less waste, reduced inventories, and significantly less obsolescence, using less water. You don't have to use cliches anymore. You go directly to paper, and therefore you save a whole branch of an industry that is supporting the printing industry with quite a lot of heavy-weighted chemistries. So we don't need this anymore when you go direct to the board in printing. There is a lot of flexibility involved in digital printing, and because of this, you waste significantly less effort and time. You can go to a higher level of automations, and this is another level where we can bring employees to a higher level of performance and higher level of education just by moving to digital. As there are significantly less chemicals, and specifically to the HP solution, we have chosen to go with really water-based solutions. And in that, I will soon hand it over to my colleague, to Xavier, to really explain why moving to water-based solutions can be of a significant importance to the planet that we operate in. So with that, Xavier, maybe to you.
Yes, thank you, Eviatar. So the purpose of digital printing and the solution of HP is to not disturb the circularity of the production of boxes. Boxes and packaging are a heavily circular industry that is good for the sustainability, because more than 94% of the boxes are later on recycled into new boxes. And therefore, we want to be sure that from the selection of the raw material that are used into our ink chemistries, then on the way that those chemicals are applied onto the corrugated, and also on the type of corrugated that you are using, that you are not impacting the ability to stay circular. Then the lifetime of the box should be similar into digital production or into analog production, and the full steps that we did before should lead us to allow a disposal of the box within the tolerances of the different regulations inside Europe, which are focused on the chemicals that are used for the production of those boxes. Maybe you can give me the next one. Okay, so I try to represent in a gradual way several factors that we should look at if we want to know something about sustainability. I will start from the left on the environmental statements. Every company is allowed to make a statement about its environmental credentials. Now you need to know that there are some ISO norms. You see here I put the number, the 14,020 series, which are making kind of ranking in between the different statements. At the base, you have what is a general statement let me say, like in the Wild West, my elixir is solving everything, and then you make the statement, but it's your own words and there is nothing behind it. And on the second level, you may have had a lot of chemistry, toxicology, scientific experiments that you build inside your own laboratory to sustain your declaration. And then you make the declaration yourself based on the fact that you have discovered. But the way we have been choosing to go is for the superior level, the 14,024, which is doing all the experimentation inside, having all the chemicals that we are using listed, and then opening our books to a third party so that he can verify everything about our formulations and our use, and he can state if yes or no, we are environmentally right with our formulation. We think that it's a more open way, and it's a more solid argument when a third party, which is neutral to this, can make the statement. So that is for environmental statements. Then, as we are speaking about sustainability, and sometimes sustainability is a difficult word to define because it's multi-criteria, we can have a look at one of the important criteria, which is the renewable content into ink formulation. And you need to know that this pyramid is going, as you can see on the right hand, from the reactive ink to the oil-based inks to the hybrid technology, and then finally to the true water-based technology. The renewable content evolves as this gradient, meaning UV inks are typically less renewable than water-based ink. There is an initiative launched into the United States, which is called the BRC index. Typically, a UV ink would score a rating between 0 and 30% on the use of renewable content inside the ink, which is an indication that you are using resources from the planet that are not easily replaceable. When you go for water-based, especially the water-based of HP, our rating would be in the range of 78 to 80%. From the word, you understand that water-based use a lot of water. We all know that water is a resource that we can renew and that is circular because all emissions become vapors, vapors goes into the atmosphere, become rain again, go back into the water, and etc. It's a loop that we have. It's not only about the water, it's also about other chemicals that we use, specifically the renewable source instead of the non-renewable source, even so that it was maybe more expensive. That's for the renewable content. If we go now for the end of life or the circularity aspect of the lifetime of a box, you would say that the base ink is to be recyclable. Most companies are claiming to be recyclable. Now, it's more that you look for the inkability of your prints. So you are able to remove the ink from the cardboard, and that's one thing. Then how much of the chemical content remains? That is what the inking process measures. It measures optically what is the quality of the recycled paper that you are able to generate based on a certain composition of waste. I insist that it is optical and it is not necessarily chemical. If you would look at the chemical content of a recycled paper, you would find a very large spectrum of chemicals present into a recyclable paper. And this make in some geographies, and I listed on purpose the BFR 36 here, which is the German regulation on recycled paper to be used into the food packaging. It's not allowed to use some specific chemicals, and they are normally photoinitiators and reactive content into a recycled paper that would be intended for food packaging. So when people say it's recyclable into something, but not into the same application that you were necessarily doing in the beginning. So it's more that you are doing an elliptic path rather than a circular path with your paper. Then if you would go for one grade higher than recyclable, you would go for biodegradable. it means that eventually Mother Nature can take care of degrading the packaging by itself. At that moment, you would not have a waste that pollutes optically the environment or things like this. Now, the thing is that biodegradable is not necessarily safe for the nature or for the health of people. It's degraded by the nature. It's not safe, right? Then you go for what we consider the crown, which is the compostable recycling of corrugated box. Basically, you there have two types of compostability. You have the industrial one and the home compost. Industrial would then require collection, sorting, and an industrial process. That process, the collection, would have a carbon footprint. Therefore, we have given the prerogative to home compostable, because when it's home, there is no sorting. It's by the consumer, but not in an industrial plant. There is no need to collect and to process industrially. You put it into your compost at home, and eventually you're going to spread it on your vegetables and onto your garden. So that's there, that it's very important to analyze the chemical risk that you have into the compost, and the prints that are done with the HP products, they are safe. You can grow your vegetables and not risk anything from that perspective. Then, as I was saying, on sustainability, you also have a part which is linked to the human and to the nature or to the animals. Then you need to do certain toxicology analysis. You need to know that there are very big differences in the different ink technologies. So let's take, for example, the reactive inks. They are known also under the name UV inks. It means that the chemical nature of the ink when it's in the liquid state inside the bottle and the chemical nature of the printed layer, which comes after curing of those UV reactive, is totally different, because you create a polymerization under the UV lamp. Therefore, the chemicals are different. Then there is one part that can be uncured, because you know that corrugated cardboard is a porous material that will absorb the ink. It's also not transparent, therefore it will not allow the curing to happen in full. Those photoinitiators are aggressive products. They are toxic to the aquatic sea life, therefore they must be looked at carefully. If they are toxic to aquatic sea life, you understand that they are also not recommended for ingestion by the human being, right? Then another ink technology could be the oil-based inks. Then in oils, the problem would be more linked to the aromatic and saturated hydrocarbons that are sometimes subject to creating the cancer into the human body. You cannot separate very easily and 100% cleanly into the process of oil diffraction those chemicals. Therefore, there are always some traces. Therefore, we consider that it's more a danger to use this. Then you have hybrid technology. Why is it called hybrid? Because it's still using photoinitiators into the formulation and as a fixing and transformation way. But the way to carry those photoinitiators from the bottle or more from the factory onto the print is using a vehicle, and that vehicle is the water. It's a liquid. Then what do we call true water-based technology? In our case, it's a full water-based solution. Therefore, it's a non-reactive ink. Water is the vehicle that transports the pigments and the resins from the bottle onto the corrugated, and then that has only one function: to evaporate. Of course, we know that water is not a toxic product. I guess that your doctor, like my doctor, is advising to drink 2 liters a day. So it's harmless for us. Then the ink technology is non-reactive, which means that the chemical nature of the substances inside the bottle or onto the corrugated is the exact same. Why does it matter? Because in order to demonstrate the compliance, for example, in the area of food packaging, you need to go to a laboratory that will make an assessment of the chemicals that are there present. The advantage of having a non-reactive ink is that the chemicals are identified from the beginning. They are into the statements of composition, the formula that we need to deliver to the lab. They know what to look for, and then once they have confirmed that what we told them was going to be there is there, their work is quantified. It's relatively easy. When you go for reactive ink, inks will react with themselves, yes, that's the purpose, but also with everything else what they will find. And therefore, the spectrum of chemicals which is there to be evaluated and looked for by those labs is totally different. It will make the operation more costly and more complicated for them. Therefore, as you can see, the CV150 that are the inks in use into our C500 or the A30 into our T1100 and T400 series, they have gone through the whole scheme. Intertech declaration, third party evaluating our formulas, the home compostable by the InsertCo, all elements were sent to the lab for them to grow and vegetables and to do some chemical assessment. PTS for the de-inking, because yes, we also want to know that the inking works. And then finally, we submitted the full system and the ink to Ecologo, and Ecologo is an assessment, multi-criteria of the sustainability of the technology. So with that, I think we are trying to cover as wide as possible the topic of sustainability, which is, as I was saying in introduction, a multi-criteria and relatively complex.
Perfect. I would just add, Xavier, and maybe you can correct me, but I think that when you have an ink that is free of the reactive chemicals, you're just free of concerns, because when you apply in a system, then system variations happen over time. Maybe more UV light, maybe less UV light, depending on the lamp life and all of that. So you are always on the edge, and you don't know exactly where you are relative to well-organized lab tests. But when you are free of these chemicals completely, then nothing happens really. I mean, it's always safe, right?
Exactly.
Very good. So with that, I'll just summarize maybe. And again, consumers want better experiences with less environmental impact. And I believe that HP is addressing this in the best possible way. As it becomes more ingrained in the brand-to-consumer relationships, there is clear opportunity to win favor with the right approach. The need for printing with the environment in mind is growing, and it is something that brands are capitalizing on to increase their appeal and drive purchase. And HP Paid-Wide digital packaging plays a major role in providing a perfect solution that fits this demand. So this is our statement really, with all the power of HP behind. So with that, we conclude the presentation.
Fantastic. Thank you so much, both of you, for sharing that information. It's so important to think about, you know, the many impacts, you know, that we have on the environment, and how we can make sure we're being as sustainable as possible. And it is clear, you know, we have a couple of minutes left just to ask a couple of questions, if that's okay. But it's clear that HP, you know, is HP Paid-Wide, that, you know, there is this sustainability built in. It has sustainability in mind, but how is that translated to, you know, on a day-to-day basis? We've had that great overview. How is it translated to the daily kind of work on a converter?
So, you know, there are two components there really. One is the fact that it's digital, which again means significantly less waste, highly educated employees, saving on make-ready, saving on intensive cleaning cycles that use a lot of water, less emission. All of that is embedded into a digital solution. But to go the next step with what HP is offering with the water-based, pure water-based inks, is really taking it to the extreme, as Xavier just educated us in the previous slides. So it is basically, it is radically changing the life of the operator and the way things are done in the corrugated plant.
Fantastic. And just thinking about, the water-based inks, HP has, you've got a long-term stake in sustainability, as we said, and made a significant investment in that water-based ink technology. As there are more and more water-based inks available, what makes HP's water-based ink technology special, we should say?
Yeah, maybe Xavier, you can.
Yeah, I hope that I have given some hints into that pyramidal slide. So you can know that, first of all, water-based inks is not a wording which is regulated. So it's true, there are all types of water-based inks available right now. The difference between the HP one and the others is that it was designed with the intention to be compliant with food regulation. So safety was the core of the design. We don't want to risk either the business of our customers or the health of the consumer with that. And we have decided to go for the best elements, the best ingredients, the safest way to produce it in order to cover for that. Our intention is to be valid for the food packaging and therefore safe for the other applications as well. It may not be the scope of others.
Yeah, I can tell you, Caris, that it would have been so much easier for HP to take the UV-based systems that we had in the past and promote them into the corrugated industry. And some did this way, but we decided not to take this easy path and to really invest into making the solution right for this industry, right for the planet, right for the people using it, right for the people consuming it. It was very important for us. So we took the extra effort in order to make it right and all the way to the end.
Fantastic. And with there's a number of kind of UV based presses, it's out there, how are you now making sure that going forward, you're maintaining sustainability within HP?
Right. So, technology is progressing over time as well as the awareness to sustainability. And if I reflect back like 20 years ago, printing was mainly using solvent-based inks, which are the worst you can think of. But this was the easier technology path at the time. Other technologies were not really available. And also the awareness in the global environment to the environment was not as stringent as it is. And it's moving and progressing all the time, which is good for all of us. So with that, then we moved away from solvent with the recognition that something else is needed, went to UV. And now we are in really the more progressing stage, which is even moving away from UV and going to water-based inks. And it's a roadmap. We develop products that fit the need and the atmosphere and the environment that is around us, including all trends. And we try to meet the highest standards. And especially when you go to packaging where you're really holding the output in your hands, and your kid can take it and do something with it, play with it, chew it. You want to be very careful, and that's what we're doing.
Yeah, fantastic. Thank you so much, both of you, for joining us and being part of that really informative session. So thank you, Xavier and Eviatar, for being
Thank you very much, Karin.
Pleasure.
And thank you to everybody that watched the session and joined us for that. There's a lot more great content on the way. This is the Future Print Virtual Conference, and I'm Karis Kopp, and goodbye for now.